We have 11 questions on that been asked online, and many have voted. And I was thinking we can do alternatively one of these, and then if there's a live question from the audience, and then back to the pre-asked ones. Of course, these are the ones I've had some time to think about and research in some cases. So if there's any contradiction between what I'm saying about these and what I'm saying impromptu, the more reliable ones are the tasked one. So, first of all, what is the approach used in Google to manage dependencies and package distribution? The answer, translated into something you can use today, is spelled Bazel. B-A-Z-E-L. Actually, internally, we use a version of that tool that's called Blaze, which is kind of a cooler name, but a little anagram into Bazel allowed us to decouple it from internal stuff that's only relevant for Google's own development and make it available as an open source offering to the world. And this is, let me go to the home page. This is what is used by Dropbox, Google, Stripe, Braintree, Heron, Improbable. So don't be afraid by the fact that only Java and C++ are on the front page. Python is perfectly well supported too. Essentially, summarizing, with the Bazel/Blaze approach, you explicitly state exactly what your dependencies are in a file called build. And based on that information, the tool orchestrates all the building and testing operations that you need. You can integrate it into your own continuous development, continuous deployment system if you have one, or there's plenty of adapters around for all the most popular ones. The reason we forked our own internal Blaze is that one is already heavily integrated with all the other stuff we used at Google. For example, our source code management system is an internally developed variant of Perforce. Nobody else uses that except Google. So you're no doubt much more interested in integrating your own building with either Git or maybe Mercurial. You'll find adapters aplenty on the big wide world. So go to bazel.build and you will see all the tools that you can use that are very much aligned with what Google used internally. Any live question? It needs a mic so that everybody can hear. If there's no live question, we can just move on the list, so don't feel forced to ask. Going once, going twice. Let's move on. Particularly because it's it's actually just as popular. What do you think is the biggest problem of Python? By the way, feel free to join the slide.do, upvote, add questions, whatever. I will refresh the screen once in a while. So, the biggest problem of Python from day one, and it will never be fixed, comes in a three-letter word, pseudo word, DEF. It means absolutely nothing. It's supposed to be short for something. Default, defect. I would buy that. If you need a keyword to define a function, in the normal Python philosophy, it should be function. I'm sad to say this is one thing JavaScript got right and Python got totally, horribly, terribly wrong. If function is too long to spell, use fun. That's a nice abbreviation, or funk. Other languages do that, and they're fine. Unfortunately, I can predict with a strong confidence that terrible defect will never be fixed. You will have to keep saying def. Every time I type def, which is very often, I say, why did we use that? Well. So that's not really very constructive, because it's going backward 20 years, it's been there forever. It obviously hasn't stopped Python from becoming incredibly popular and useful. It's just great. So if you have a Pythonista's aesthetic sensibility, that design choice still great. The fact that it's been there for 20 years is not helping any. Going forward, the risk rather than problem we have is complexity. The uses of Python today are so big and so widespread that there's a lot of temptation to add stuff and yet a little bit more stuff to ease up the common uses. I hope the current steering council can resist this temptation as well as the benevolent dictator for life, our previous model of governance, was able to for so long. The fact that Guido van Rossum is one of the members of the steering council is kind of reassuring from this point of view. I'm pretty sure that the core language will not grow too much complexity, although it bears watching. The problem is the complexity ends up hiding in the standard library, which is subject to less strict scrutiny than the core language, reasonably so, because core language is something you are using every time you program in Python. If there's a module in the standard library that you don't really think is simple and straightforward, a third-party alternative is always an option. Still, if the standard library grows too complex and unwieldy, that will make life harder for future Pythonistas. Some say we already have too big a library. The philosophy of the language has always been batteries included. Too many batteries can become a bit unwieldy. We had a great talk earlier about hidden gems in the standard library. That's great, but there shouldn't be any. If you think about it, the standard library should be simple enough that every Pythonista masters it. Is far from that. It actually, about various experts were quoted in that other talk, and the optimists say they think they master 70% of the standard library. The pessimists say about 50%. That shows it's a bit too big and complex. However, again, I don't think it can be simplified because we don't want to break compatibility to that extent. We should just be on the lookout for further complications and keep it at bay. Okay, next.
Questions, meanwhile? Okay.
So what do you think about this tendency in Python to move towards explicit typing, and going along with this, a tendency to basically compile the language, either actually compiling it or just in time compiling it?
I think explicit type annotation is a great step forward, as long as it stays, as I'm pretty sure it will stay, completely optional. That is, we don't want to fork Python into two languages the way JavaScript did, with JavaScript remaining untyped and TypeScript a separate language and therefore certain to diverge in the future as both evolve with mandatory typing. What we want to do is to have one single Python, not split, not fork, and in that one single Python allow and encourage type annotations. Indeed, if you look at what the BDFL, sorry, the term is not current anymore, benevolent dictator for life, but Guido has been doing for the last few years is mostly working on the MyPy tools to integrate type checking on the outside even better. I'm entirely favorable because it makes things so much more readable for human beings. Instead, I have a def f open paren x close paren colon. You don't know anything about what the flick is this thing doing. I have to explain in the doc string, hopefully in reasonably standardized human readable terms, what's x, what is this computing, what is this returning. With the type annotation, you may see x colon sequence int arrow int. So this takes a sequence of integers and returns an integer. I still need to explain how does it compute the integer it returns, but you have a wealth of information available that you didn't have from the bare signature. The signature with type annotations tells you much more, that you can pass any sequence of integers and will get an integer in return, and now the semantics needs to be explained. I think that's definitely positive. As to how much it helps compilation, I don't know. Is Antonio Cooney still around? No, because the PyPy guys have done such a great job inferring types for JIT compilation that he could comment if the explicit annotation would be any use. I strongly suspect it wouldn't. I suspect the main use is for human readability, but that's not diminishing its role. Human readability is what it's all about. Thinking of of programs as a way to instruct computers what to do is a really obsolete viewpoint. A program main role should be communicating what it is I am doing to other human beings. As a side effect, the computer can do it for me, so saving me work. Okay? Moving on. Okay, a personal one. What's the biggest challenge you have faced as a developer? Okay, so at some point in working in business intelligence for Google, I was maintaining and developing a little tool that salespeople, sales managers, account managers, and so on would run on their workstations that went to our internal databases recording all the kind of commercial activities, ads, clicks, and so on, process things appropriately and answer questions that the Googler, especially in the commercial side of the operations, might have, such as how's the trend for clicks on ads by customer XYZ, that kind of thing. Yes, there are, of course, graphical things, graphical displays that give you answers to to popular questions of the kind, but it's also very nice to have an ad hoc way to make a specific query on the way if you, even though a salesperson or sales manager, are technically savvy and like the command line on a terminal, which is very common at Google. The program was interesting. One problem it didn't have was data access, because from any workstation at Google, there was absolutely unbounded access to all these databases. Then one day, Google found out that actors sponsored by foreign governments, which will remain unnamed, were desperately trying to hack into our systems, and a very thorough review was done of, okay, we do have security, but how much do we have? Where are our weak points? Unfortunately, it turned out that one of the weak points was a too broad access to these obviously highly confidential databases. In particular, letting them be accessed by laptops, as more and more people decided our station is clunky and they wanted to do as much as they could or everything on their laptop, made it theoretically possible for hackers to actually get that information and therefore potentially violate privacy. We didn't have any actual accident of that kind happened, but prevention is better than cure. So suddenly the edict came that access to those databases would henceforward be highly restricted, and only well-vetted and whitelisted agents, essentially background daemon production on production machines, could actually access the raw database, and the security review would guarantee that they returned a safely processed subset of data. So suddenly, my little, well, not so little anymore by that time, program was about to die a fiery death, because I couldn't possibly imagine that every workstation and every laptop in the company would be whitelisted. That would have been equivalent to there not being any whitelist at all. So, OMG, what do? The concept of suddenly subtracting a crucial daily tool from tens of thousands of colleagues was what made it very, very challenging. In retrospect, the solution was somewhat obvious, although implementation took time. I essentially had to develop a highly secure daemon running in production on our production systems, have it vetted by security, going through a security review, whitelisted, shim at the script level all the requests that used to go to the databases with a layer that would actually send them to the daemon, verify that they met one of the security approved patterns, with the variable being customer identification or geographic information and so on, and have the daemon do the query on behalf. In fact, this, once I solved this for the security aspects, it proved to be a vastly winning combination, because it could afford, for example, a lot of caching, especially towards, I don't know, end of quarter, when people are trying to summarize their results and so on. There's a lot of queries which are absolutely identical from each other. When they used to come from different workstations through the script directly to the central database, they had to be computed over and over with the shim daemon in between. The shim daemon itself could keep a well-managed LRU cache for these. So actually people were astounded to see that some of their queries went twice as fast as before. They were ready to pay a price in slowdown for this more complex architecture, but it turned out just beautifully. Okay, this is the most challenging thing that I resolved successfully. I refuse to dwell into those which I failed miserably at, although they're more instructive. But this is something to be considered. The possibility to distribute what was centralized, or centralize what was distributed, is an architectural evolution that one hardly ever considers, because it does require a lot of rework of existing working pieces, but it may offer great advantages. So your options are either do like I did, wait until external forces make it mandatory for you to consider such options, or do it proactively in your copious spare time. Keep thinking, is this still the best architecture, or should I completely tear it down and put it back together again? I very much doubt that you will actually follow this, but I hope to make you guilty for not following this. So there's some motivation for better and more effective re-architecting. Okay.
Other question? Someone? No? I got one question. Do you like pancakes?
Do I like what?
Pancakes.
Pancakes? Yeah.
It's a complicated question, but I know you can answer.
What kind? I mean, the American fluffy kind or the flatter crepe style ones? They each has pluses and minuses. I particularly like savory ones in the Normandy tradition.
Okay, now I'm complete. Okay, you can go on. Thank you.
Okay, so gravitated to the top of the list is a relatively new question. What future do you see for Python in the async direction? How do you compare it with Go under this respect? I believe that Go has its own very interesting architecture, but most other languages that, as I see, are converging to the same model, including the same two keywords, async and await. I believe C# introduced the keywords, at least among the widespread languages, but JavaScript has them now, and Python has them now, and between the two, we're talking about by far the two most widely used languages in the world. I expect that will grow. I think there will be a flurry of initial enthusiasm, and then people will realize that it's really great for a small but crucial subset, 20, 30% of what people write, that has to do with either networking or other vaguely similar situations where there may be long waits in which the CPUs would have nothing to do if it was a synchronous call. I predicted in any language it will work more or less the same, whether it's C# or JavaScript or Python. The semantics of those async and await are really close to each other. They fit as slightly different in these different languages, but not by orders of magnitude. The advantages and the difficulties remain the same. Of course, if you compare it to other approaches to async, like callbacks, they are just the cat's pajamas. They simplify your life with essentially no price to pay. So if you're used to doing async with callbacks, for example, in Python with Twisted, or in JavaScript, in native JavaScript, you will absolutely migrate, because there's no reason to keep doing things the old way. But the vast majority of stuff you'll be doing, unless your job is in maintaining web servers or something, probably will not really benefit from it. Go is a different approach, and I would like to come to it in the response to a further question right down what the Python equivalent is. In Go, you should probably be using channel and Go routines for much more than you'd be using async in JavaScript or Python or C#. That's a slightly different thing.
Oh, one question. Thank you, man.
Thank you. With the end of Python 2 coming up in less than a year, are you aware of any remaining concerns around that event?
Absolutely. I am a bit surprised that no high initiative entrepreneur has yet announced a commercial offering to keep supporting Python 2 forever for a fee, because that is what I strongly predict will happen. There are companies which have huge amounts of Python 2 around, and they don't want to stop the world and convert everything to Python 3. And neither are they particularly happy of having to take on the maintenance of Python themselves. There are enough of those that a startup, it doesn't take much. 3-4 strong core developers could keep it going forever, making sure at least that all security patches are applied and so on, even though the PSF isn't doing it anymore. They will not be doing it for free, but if there's enough customers, and I suspect there would be, the continuation should be guaranteed. Apart from that, the pressure to migrate to Python 3 can be a pain point in many cases, because you're moving to a better language, but it does take a little time to do so, and during that time you're not adding features to your offerings, and so presumably you're not going to be directly paid for them. Sad, but eventually it had to happen, like with any other language. What do I think about Rust? I love it to bits. Unfortunately, I haven't had an opportunity to use it in anger. So I played with it. I keep reading all the docs. I notice it changes at a speed that would make me extremely wary of using it in any production environment. It will stabilize, no doubt, but it is not what you would call a stable language today, especially for the kind of applications it will be best at, which are kernel or near kernel level, where they increase type security that goes well beyond whatever C and C# and the like may have ever provided, are really worthwhile, worth the, I suspect there will be quite an amount of adaptation from looking at it like for fun and actually writing it in production if I ever get the opportunity. I may. Google is developing a new operating system using mostly Rust, for example, so I could find an opportunity to work with that team. The biggest strength, I think, it brings to the table compared with existing languages is to consider scope as lifetime of a variable as a crucial part of the, let's say, type or extended type of the variable. A variable which is guaranteed not to go away for a certain span is a different type than one with a different span. You can't, it's wonderful that the compiler makes sure that you're not using a variable beyond its guaranteed lifetime. Actually ensuring that when you're programming beyond the toy level, I suspect will be the greatest challenge of using Rust in production, at least for me when I come to that. But it's a great idea, and it's amazing that nobody before Rust had thought of it.
Okay, question? Oh, you're fast.
So what do you think about these Pythonic conferences and Pythonic conferences in general, and one, it's your suggestion to do better Pythonic conferences in general, or subject, or I don't know, way to discuss and grow the communities?
In the past, I've gone to many different kind of software conferences, and I find that in general, the crowd, the audience at the Python conference is the coolest. I really enjoy those. How do we make them even better? Well, maybe find a better place to have the social dinner. The only one point I found myself wishing for the way it was done 2 years ago with the social dinner. I understand the previous venue was not really fitting with our needs this year, but this isn't so much about Python. I suspect if it was a conference about Rust, we'd still want a good dinner. So they not really language specific, I think. Like concentrating a million lightning talk in an hour plus may kind of discourage people. Having a bit more distributed times, like for 2-3 lightning talks during transition between sessions, that might be something I've never seen done before, but it might be worth seeing if it actually improves, because maybe I get an idea for something worth discussing 5 minutes from a talk today. Too late, the lightning session is past. Maybe if we had it like shorter and 2-3 times in each day, maybe that would work better, would be worth considering. A bit difficult to organize, it's always, but the organizers are brilliant people, and so they deserve to be tasked with harder jobs.
She's smarter than me, sure.
Okay.
So, go on.
Next, which is the most common error you see in developers approaching Python for the first time? I actually think there's a big difference between people who are completely new to programming and who are learning Python as their first programming language versus people who come to Python from previous experience with one or more programming languages. In the former case, the people who are completely new to programming, you tend to see roughly the same kind of conceptual problem you see in first-time programmers using other languages. If you've never interacted with a computer before instructing it what to do, the mental problem, not really language specific, is that the computer will do exactly, literally what you specify. This is not what your life experience interacting with other human beings trained you to do. I've never dealt with?
Stop.
Obviously, you've never dealt with toddlers.
Oh.
Dot.
I have, but maybe I don't. I didn't Are they supposed to be the ones doing exactly what you tell? Because this isn't my experience with.
Exactly what you tell, not what you mean.
In my case, they didn't do what I told. Anyway, but the compiler will. But this isn't so much a Python problem, because I say most every language, maybe Python and other very high-level languages are kind of more vulnerable to it, because so much in them seems to match human thought, while if you're programming in assembler, there's really such a huge gulf that you don't risk confusing instructing the computer with communicating with a human. With very high-level languages, of which Python is one, you do. But more interesting, I think, is to see what typically goes wrong with Python newbies who are not newbies to programming in general. They have other experience. I generally see them automatically, like without reflection, pick much lower level approaches that will eventually work, but take a lot of work to write, a lot of work to maintain, and will run slower. And when they're done with it, they complain, oh, this Python doesn't really improve my productivity, and it runs so slow. If they took the bother of learning the conceptual differences, Python will let you do things at a pretty low logical level, just because sometimes you may need to, but there's usually a more abstract and faster way. And the main problem is that people coming from most other languages, typically lower level ones, don't really get that.
Someone?
A question, a little bit what you mentioned in 2 points before. You mentioned Rust before. It was through Mozilla Research and then through Servo. Now is in production in Firefox. But in general, when Do you have any suggestion of good practices when a big project has to be rewritten? For example, also in Python, there is a lot of project can be rewritten in Python. And what's your best practices also in the decision making in order to make the decision and then proceed in the process?
So I strongly recommend a book which you can find for free online, but it's actually, in my opinion, worth having on paper. It's called Software Reliability Engineering. It's written by a bunch of folks at Google who invented the practice, which in practice invented DevOps, but called it system or site reliability engineering. There's a collection of best practices, including real-life examples of cases where they were not followed and the disasters that ensued and why the best practice was codified. In open source systems, you hardly ever see that applied because it's really, unless you're like completely steeped into it, it's a really hard way to think. One example is canneling. Possibly this thing, if you have to single out one best practice, is you never upgrade 100%. You randomly pick, if your installation is big enough, 3%, 4% of the queries or actions to use the new release and monitor them even more carefully than you're monitoring everything else. If they work fine, you keep slowly replacing the previous release with the new one. This is never done in most software releases because they're not living online. They still live in an ancient world where releasing a pieces of software meant printing a CD and sending it out in the mail. This isn't the way the modern world works, but it's still what we are kind of unthinkingly using when we think about, for example, releasing upgrades. How do we apply canneling, for example, and other great practices you'll find in that book to, for example, a project like Python? I don't really have a great answer right now, but I think that is what should be happening if we had our druthers. More advanced release engineering than just about any other piece of open source. Possibly the best handled one are operating systems. If you look at Linux is sometimes a bit chaotic, but if you look at something with less huge footprint and a bit more structure like FreeBSD, you will see how they handle new releases. And I think you could find, even though you don't care about the specific operating system, the very practice is instructive. So I recommend like taking a pointer from that. Why don't I full screen the browser on the desktop? Okay. Because I don't know how to do that. So, as you see, after looking, you now have 11.2% larger. That's, if anybody can swear on their honor they see the difference. That's why I give up on full screening. It doesn't really matter. I don't count this as a question, so I'd like to move to another. Do I think artificial intelligence will rule the world? I think it's smart enough that it probably already does, but in a hidden way. Okay, any real question?
Someone got a question? Oh.
Do you think there should or could be some, even should, it's not a rhetorical question, way to have big IT companies contribute more to open source if they benefit from it? In general.
So got this question in a different context, and I went and curiously counted every Google contribution, Alphabet more generally, but it's almost for Google, contribution to open source. I counted 2,700 packages. Do you really think that if there were 5,400, you would be better off? I mean, you probably don't know and haven't even looked at more than 200 of them. What's the point in wanting still more? I don't get it. That I suspect that what people would really like would be to see not packages but money, but things like Google Summer of Code and so on are...
No, I mean, it was really not a regard to a question, but the inspiration came from some discussion from the big Linux kernel bugs which emerged a couple of years ago. This was more or less the context. But I like the answer, thanks.
Linux probably doesn't need thousands of packages per se. If I counted thousands, but in such huge variety of fields that they kind of make sense, although many of them may duplicate other existing functionality. For example, Bazel, which I mentioned, is far from the only build system conceived to integrate in a continuous deployment system. It's just that a few companies, not just Google, but Dropbox and so on, think it fits their needs better, and so they open source it and they all contribute. Next. Favorite new thing in Python 3? This one I had a little time to think about, and I think if I have to single out one, is that just about everything that, if you didn't know better, you might think it would return a list, now actually returns an iterator. That you had to, you could get the iterator in the previous. For example, instead of calling dot values on a dictionary, you would have to call dot iter values. And then you'd get an iterator instead of wasting memory to build a huge list. Instead of range, you'd have to call xrange, which isn't an iterator, but it kind of can pass for one in the dark. And so on and so forth. So you had a lot of dishomogeneous ad hoc solution to get iterators instead of lists. Now in Python 3, essentially you can trust that if it makes any sense for the behavior of something to be an iterator, it will be. Dot keys, dot values, range, everything is an iterator for you. If you want a list, for whatever reason, it's going to be rare, but then you explicitly call list, open paren, whatever, close paren. Explicit is better than implicit. That's of the many developments, this one is my favorite.
Your turn? Someone? You? Okay.
What would you think about adding an explicit pattern matching switch like we see in Rust and in functional languages for table-driven and so on?
So pattern matching is a concept, of course, in any language, and Rust is not a functional language, but it does have pattern matching. SQL is not a pattern matching, but it has a case instruction. Should we have in core Python as an alternative, presumably to a if-elif tree, a new statement? I think it would be quite hard to make a case for a completely new statement, but out of the several you could conceive, case like one would probably be the most defensible, yeah. Because the problem with if-elif, it's intrinsically sequential. It superimposes a sequence, a specific order in which the tests must be made, while a case would allow non-determinate, which is actually good. It's the general idea, if I need to do two things, say, I need to assign to A an expression and to B another expression. In just about every language in the world, I have to decide in which order the two things happens, even if it doesn't matter. That's a pity. I wish I could tell the computer and the reader, these various things happen in any order, there is no determinate thing. That's unfortunately not present in any language that I know of, but a similar thing happens in testing, in checking. If you have to say if test, elif test, then the second one will be asked only if the first one failed. Intrinsically, you are superimposing something your actual problem may not need. You may know that the tests are mutually exclusive, so they could technically be all done in parallel, but you have no way to express that, and that's a pity. By the way, not all languages have a case semantics that guarantees mutual exclusion. So a case semantic that is just syntax sugar for if-elif, I'd rather not have it. If I did have the syntax, it would have to reflect the semantics. Moving on. Sorry, but the thing keeps updating. Top 3 qualities to be a successful developer. Counterintuitively, I'll put selected soft skills at the top. Most people think that the core of a developer is all about technical, brainy stuff, and of course it matters. But the ability and willingness and eagerness to help others on your team, help others in general, and to get help from others, I would rate at the top. I've seen brilliant people waste 2-3 days because they were too proud to ask for help, and in fact repeat a solution that already was existing, just not known to everybody in the team. They were too proud. More rarely, but it's happened, I've seen people ask for help and saying, oh, go away, I'm too busy with my own stuff, when in 5 minutes they could have saved the teammate 2 hours. This may seem good things for your career or where your development in the short run. That's a mistake. They are not. They're going to hurt you. If you really like to help others and really like to learn and be helped by others and not too proud to ask, that will help you enormously. Beyond these soft skills and what they entail, because for example, the ability to communicate, for example, say you have a problem, the ability to explain what is your problem, or somebody else has a problem and asks for help, your ability to explain the solution, so communication abilities are needed to make willingness and even eagerness to help and to be helped effective in the real world. On a technical level, I will accept Knuth's determination in the matter. The rare and precious skill, and by the way, this also answers the following question, which only asks for one thing, but specifically concept, is the ability to see the big picture and the detail at the same time. So a kind of strabism that lets you seamlessly deal with minute details without losing track of the big picture, and vice versa, shift the big picture in response to external needs changing, for example, while realizing what all this will mean in change of the details. I'm told this is exactly what qualifies you to be an alchemist, to see the microcosm and macrocosm with the same eyes. So alchemists should try their hands at software development and vice versa, though I wouldn't know where to start to try my hand at alchemy.
Question? No. You? And you? Which one? Go fight. Okay. It's fair. You're a good man.
Yeah, what was your view of the process of PEP 572 and how it led to, or seemingly largely led to Guido stepping down, and then what do you think is best going forward?
I think that if you were loading a camel and at some point in the course of putting stuff on the camel's back, the camel fell to their knees, you would not be particularly well inclined to examine the last thing you put on the camel's back. Oh, what makes this straw different from all other straws that I have put on previously? Not necessarily anything, it's just that at some point the total stuff exceeds the camel ability to be patient and supportive. I think that 572 wasn't actually particularly more controversial than other things in the past. It's just that the very rude overall reaction of parts of the community was the straw that broke the camel's back where the BDFL was concerned. He just couldn't take any more of such rot. As for the technical content of 572, by the way, I 100% agree with Guido and regret that I had not entered the discussion at the time because I was hoping it would die down. I didn't want to rekindle it, my bad. As I'm sure that applies to many other core developers, we didn't want to all pile in and just make a huge fire. But that's relatively secondary issue. I hope the people who were responsible for the rudeness will learn something useful from it, but I kind of doubt they will, but that's a different issue. How much longer do we have?
Not that much. What do you prefer?
So shall we stop the...
It's true.
And just...
Wait.
Okay, so about the data science, I'm not really qualified to answer this question because my maths has always been one of my strongest qualities, so I have a hard time thinking, if I didn't have that, what would have worked? I would like to crowdsource this. I don't think we have time in this context to actually do so, but is there an ongoing like Slack discussion channel that will not like die down with the conference, right? So maybe we could use that, and maybe somebody with experience teaching this stuff, which I don't have, could chime in. I don't know who's responsible, who's the administrator of the Slack channel. Maybe I can convince you to not tear it down, just open one specifically for discussion of how should you learn.
Yeah, that's hard because at some point we lose history, and then it's a burden also for like code of conduct.
Are there good fora existing in the public sphere about beginner in data science? If that's the best we can do, then I suggest we study something else. Okay. You said that Python is your favorite programming language, but which is your second favorite one? So I have to distinguish here. Ones I've looked at and like played with, but not actually ever used to bring bread on the table. Those have many charms which may not survive if I ever was to use them in anger. I mentioned Rust, but also Kotlin, for example, appears to be so heads and shoulders above Java, yet having the same semantics, plus the crucial type distinction of something which could be null versus something that is guaranteed not to be null.
5 minutes.
Okay. So, but I've never actually done any production work there. Out of languages in which I have done production work, I will sadly notice that right after Python, the only one who never really disappointed me was C. I know that kind of dates me, but 5 minutes. Da, da, da. Yes, software developers in Italy are indeed paid and treated less well than elsewhere. The only solution I can suggest is do what I have done, do what many others have done, find rosier climates. If eventually the Italian society finds itself scarce in software developers, then the offer versus demand balance will improve matters. Do I remember my first program? I do indeed. I have 1/3 of a talk entirely devoted to it. I was a hardware engineering student, and we wrote, the three of us, which were all Bridge fans, wrote our very first Fortran and very first at all program on punched cards to compute probabilities related to the game of bridge, which was our passion. We did 3-way checking of everything, coding forms and so on. It worked first time perfectly, no bug, and that was the only time in my life that ever happened. But of course, since I didn't write any more program for a long while, I was busy designing integrated circuits. I thought, see, these software guys have it easy. Whoops. With full screen, people don't see the URL. Great. Fortunately, I can full screen or not, maybe. Doesn't look like. The URL, I don't know it either. I went there through the Slack channel. So, okay. What library, package, or aspect of Python do you wish people knew and used? Iterators, iterators, iterators. Itertools is your friend. It's one of the best documented bits. Study it. Understand why, in the vast majority of cases, it makes more sense to produce something one item at a time rather than have everything in memory as a list. People just find hard to think in terms of iterators, but they are absolutely crucial. I already mentioned the pervasivity of iterators in Python 3 is my favorite side of it. If you ever see somebody building up a list with an append, ask why isn't he just yielding the item? In most cases, you'll find they should be yielding the item. The caller can do the list construction if that's necessary. Do I miss living in Italy? A little bit. And we miss your talks. This is not a question. So
no, apparently. But you can answer anyway, I know.
Well, I've been talking for an hour, I hope. Okay, and I think, is tortellini with ragu bad design? No, it's quite a classic. Tortellini con panna cries vengeance to the god. But brodo and ragu are perfect.
I think we have time for just one last question.
Mm-hmm.
So,
what are you doing on May 23rd?
I don't know. Is there a...
You forgot already?
Oh, right. I will be sworn in as an American citizen. I passed the exam. I plan to keep dual citizenship, Italy and America, so I can vote in both elections. That's essentially the only big difference.